Hello, my name's Chris Vane and I'm from the British Geological Survey and I'm the Coastal Change Team Leader. And one of the things that we've been looking at in the Coastal Change team is to understand processes in environments such as salt marshes and their low latitude equivalents. And here we are in the mangrove system, which is a low latitude equivalent of salt marshes. This particular mangrove we're in at the moment is in Puerto Rico, and the site is called Sebana Seca. Behind me and all around we have Laguncularia racemosa, white mangrove. Also there's Avicennia, which is the black mangrove. And these mangrove trees produce large amounts of carbon in the form of leaves, stems and roots, and then this material, when the trees died or shed their leaves, falls into very wet conditions, into anoxic type sediments, where they're often then partially degraded but preserved as mangrove peats. Before the degradation happens, what we see is that insects such as termites partially degrade some of this carbon. So the termites have a bacteria in their gut which decompose the cellulose and the xylans, and we're going to be looking at this geochemically at the organic geochemistry laboratories at the British Geological Survey. We're here in Puerto Rico examining relative sea level change, and we do this by coring down into peat formed thousands of years ago. This particular environment is the Pterocarpus swamp, dominated by this tree species, Pterocarpus officinales. Further towards the coast we have a true mangrove environment, which is saline and brackish waterlogged, and that is dominated by two species of mangrove trees, Laguncularia and Avicennia. What we do is we take a transect from the freshwater environment through towards the coast into the mangrove and examine the basal peats, which is the peats which are formed on a hard surface by coring down along a transect. As you can see, it's a very dynamic environment with lots of degradation of material, both by initially by insects such as termites, and also there's large numbers of fungi and bacteria degrading the organic matter in different ways, which then gives us different types of peat forming.